Welcome to this workshop. It's one of the series that we offer as an introduction to HPC. So it actually touches on three different things that I think are quite useful for you. One is it's the introduction to another aspect of HPC. It's also an introduction to statistics and an introduction to using Matlab. So statistics is a very important part of AI, which is all the rage right now. So it provides a foundation for data analysis, modeling, decision making. So statistics serves as a backbone for many of the tasks in predictive modeling, pattern recognition, and data interpretation. We often think of these models as black boxes. You have a large data set, and it comes back with a prediction with varying levels of confidence. But you can get all of that done without understanding the underlying math or the underlying statistics. So this gives you a little more exposure to what goes on behind the models and some practical hands-on application of them. Interestingly, the new NVIDIA GPU, which will be available in the next few months, is named, starts with a B, so B100, after David Blackwell. Prior to that, we had K, which was Kepler. There were P100s, which was Pascal, V100s for Volta, and then H100s for Grace Hopper, and then now we have David Blackwell. So he is famous as a mathematician and statistician. So he did a lot of the pioneering work in Bayesian statistics, and we'll have a couple of examples of those. So Bayesian statistics is a really foundational part of machine learning and probability theory. Matlab for the University of Arizona. We have a campus license for it, but it's become a little more complicated due to their new licensing terms. So Matlab on HPC has some changes, but we are using a default version, which is a little older, which doesn't require the change, which is how the authentication works. And then the general license for HPC, if you're doing desktop work, that has changed, and I'll show you that, although it's not really designed as part of this course. So why might you want to use HPC for Matlab? Well, it's really good for large data sets. That's kind of the strength. So you can use the parallel capabilities of Matlab to run your job on a whole compute node, say on Puma. So if your workstation laptop has 4 cores, 8 cores, well, the ones on Puma have 94 cores available to you, and almost 512 gigabytes of RAM just in one compute node. So it's great for large data sets. It's also very, very good if you want to run the same job many times at the same time. As long as the data is independent, you can run hundreds of jobs at the same time. And you can collaborate on your data, so you can have data kept in a common source that everyone has access to, and you can set your permissions as appropriate. And then the last advantage here is that it looks similar to how a laptop works, and I'll show you that. We're going to be using the Statistics and Machine Learning Toolbox from Matlab. Here's just some comments of all of the different things that it has in it, and this isn't even all of them. So let's flip over and take a look at the source where I'm getting this from. If you use, Google and put in Matlab Machine Learning Toolbox, is somewhere you should get something similar to this. You could go to one of the other links, but this is the one that goes directly to the toolbox. And you should see this page, may change over time, but something like this. And then scroll further down below the description of what it does. Here are the different toolbox entries, and we're going to go through quite a few of these. So you can do your own version of this workshop just by following the examples in here. The advantage of the workshop is that it synthesizes a lot of them down to a few, and even takes examples and makes shorter versions of those. While we're over here, I want to just jump over to what I referenced as how the university handles the desktop version of Matlab. So you want to be using a service called VCAT. vcat.arizona.edu will go to here. And you can scroll through all of the different apps, Jupyter Notebooks, and you'll end up down at Matlab. And you can launch the VCAT virtual machine version of Matlab R2023A. So I just want to point out that this is how you get to use Matlab on your workstation. What we are going to use is HPC. So it's going to look like this. This is where you'll land if you go to, you can see up in the top, ood.hpc.arizona.edu. You need to have an HPC account to do this. And once you have your account set up, you can click on the Matlab GUI. So now I'm on a login node. So I'm setting up the environment of the resources that I want to request. I choose Elgato because that's set up as an interactive source. It's designed so that you should get fast responses to your sessions. Puma is very busy, so you may wait a very long time to get a session started, and you don't really want to sit around and wait. I choose the Matlab default version. If I pick a newer one, it requires authentication, which is fine, but for what I need, I can use the prior version, which doesn't separately authenticate. I pick 2 hours for the runtime. I picked 2 cores, and I'll show you the consequences of that in a minute. 4 gigabytes per core is how much memory is on each core of Elgato, and then my account. So when I click launch, it's actually starting to set up my session on HPC. And so often it's 5 to 10 seconds, something like that. So in this case, 5 to 10 seconds is how long it took. So now I have a session available on one of the compute nodes that happens to be called CPU 45. And I click on launch the Matlab GUI. I don't need to change anything else. So it's setting up a virtual machine for me. The first time you do it, it'll take a little while because there are a bunch of files it has to set up. So the 2 things that I want to point out here is, remember I said I wanted 2 cores, so it's responded and giving me 2 threads, which for Matlab terms is the same. So now I can operate on 2 cores. The other thing to point out is where it took me to. This is my home directory on HPC. So within my home directory, I have these folders, so I can navigate to find the files that I needed to use. So I might have uploaded files to bring in to work on. So it navigates really quite simply. For the virtual machine environment, we use cut and paste. So an easier way to do this is to just open the file that you need, but I'll show you how to cut and paste. So when I open that little triangle over on the side for VNC, the virtual machine manager, and open a clipboard, I can then take the data that I need as examples and paste them into here, and then I paste them into the document. So in the examples of what we're doing, I will hop over to our documentation. And in our documentation, there are workshops. Here's some material for statistics. Here are the examples. And it opens up this file. So if you haven't, the easiest way is to cut and paste this file, this text, into a file, and then upload it to your HPC, and then you can open it and just cut and paste. Or alternatively, you can cut and paste out of here directly. So for example, the first data set is called Carbig. I'm going to close this out since I don't need it anymore. And I go back to my clipboard on HPC. So I paste that in there. That was just a right click and paste. But from here, what I have to do is right click, copy, go over to my window, right click, paste. Okay, so it's loaded it up. Just wanted to point that out. So if you need to use a clipboard, you can use it that way. Or I could have just opened the file if I had it here ready to go. So from here on, I'm going to be using the PowerPoint version. So I'm not going to be doing the live demo from here, but it's going to look just the same as this process. Okay, so we've hopped back over to the demonstration. So in the document that's in HPC docs, and then this video course, here's that same step. So we open Matlab, set 2 cores, click on launch. It starts a session with 2 threads to a home directory. All right, so here's what we're going to be going through. The statistics and machine learning toolbox comprises all of these different tools. We'll be going through most of them. So you can follow along at your own pace, and I'll show you examples where you can take it to further depth or use different examples. The first one, descriptive statistics, that's to understand and describe large data sets of data quickly using basic descriptive statistics, including measures of central tendency, dispersion, shape, correlation, and covariance. And I chose visualizing multivariate data using 3 different statistical plots. So let me hop back over to here to show you what I'm talking about. So from here, statistics and machine learning toolbox, I scroll down. Here's the first example, descriptive statistics and visualization. Click on examples. And then I chose visualizing multivariate data. So I don't need to hop back and forth for all of them, but I just want to show you where I got these from. Okay, back on the demonstration. So I've got a capture here of how to do cut and paste that I just showed you. And again, that's an alternative to downloading the same file, the text file, and then opening it from within Turbo VNC. So this demo, as with most of them, is cutting and pasting directly from the examples. So this one, we load a data set. The flow is similar, say, to RStudio, but some of the terminology is different. So, with Matlab, load is the word to bring in a data set. And the data sets are included, as opposed to like RStudio, where you might have to go get it and then create pull in a CSV. So these ones are all present, which makes the demonstrations easy to follow. And this example is, it's really old data, but it's just a simple example of the correlations you can find between the car's efficiency of miles per gallon and comparing that to the size, weight of the car. Yes, there are no Teslas here, no efficiency of electric motors. And then we create a plot. So we see here the correlations of the different variables, and it creates a set of matrices for scatter plots. There are often different examples. So that was a pretty simple one, but there's another one that's quite nifty, the parallel coordinates plot. So that's doing more than just 2 variables at the same time. So if you want to find out what these things are actually doing to understand better the underlying math and the underlying principles of what it's doing, it starts to get into very great detail on statistics. So you can follow along with what it's doing. So for example, and I won't do it with all of these, the parallel coordinates plot, we have the scatter plot matrix. It displays the one above showed bivariate relationships, but there are other alternatives like this one to investigate higher dimensional relationships among variables. The most straightforward multivariate plot is the parallel coordinates plot. In this case, the coordinate axes are all laid out horizontally instead of using orthogonal axes, as in the usual Cartesian graph. Each observation is represented in the plot as a series of connected line segments. And for example, we can make a plot of all of the cars with 4, 6, or 8 cylinders and color observations by the group, which is what this one is doing. There is another one called an Andrews plot. And this shows more of the underlying math. We've got square roots, sines, and cosines involved, which create the curves. Okay, we're going to move on to cluster analysis, which is a very common kind of a machine learning workflow. In this case, we're looking for data that falls naturally into groups or clusters of observations, and you're looking at characteristics of objects that are similar. We use k-means. This is a long example on their website, so this is a good one to play with if you really want a pretty good understanding of k-means. So an example of where this workshop and the tutorial take you into a depth that are actually quite instructive, as well as just some quick cut and paste to look at how things work. As an example, this silhouette plot here, this tells us that cluster 2 has a tighter correlation because it's more rectangular. Cluster 1 tapers off, so that indicates that some of the data points look a little bit closer to the other cluster. So that's kind of how to read this one. And you can see this in practice. Cluster 2 is red and it looks more discrete, whereas cluster 1 is in blue and it's a little more scattered. There are a couple of the red triangles that look closer to the blue. And there are centroids here, which are hard to see, but they are circles with an X inside them. And I guess this cluster, which is tighter, more accurate, I think the centroid is here. So again, what this example is bringing in the very classic iris data set, and it shows some of the for the plot, shows how we create looking for clusters, and then we show how to plot it and set the descriptions of the labels for the axes. Okay, moving along to ANOVA, analysis of variance. So we're looking at factors, the levels of factors at a fixed set of values, and to determine whether different factor levels lead to different response values. So this starts with, we go through, this one also is more elaborate, and continues into F statistics and variance components, uses mean squares and confidence. Also an older data set called mileage, and then we define our terms, and then it comes back showing in here. I'm going to go back over to the Matlab site. So let me just show you where I am at. All right, so ANOVA with random effects. So same thing here. I'd just like to point out also that if you're following along, it's really convenient to use this function to copy the code block. So if you cut and paste it works really well just to copy the whole block of the code that's here and then paste it in. So as a result, you get the analysis of variance here. Sum of the squares, degrees of freedom, the F value. And when I go back to read what the purpose of this particular example is, the example takes into account the random variation of the effects of the variable car model from one factory to another. And what we've found from it is the effect is still significance, and it shows the p-value 0.0136. So there's this shows you the statistics that we get as a result of running this function. And as I mentioned, you can go a lot further into that particular example. I just wanted to pick the start of it to kind of give you a flavor of it. All right, I mentioned at the beginning David Blackwell, so here's Bayesian analysis. And we're going to use this for regression. So we're using the Regression Learner app. I'll back up to train and assist models using linear regression, Gaussian processes, support vector machines, neural networks, and ensembles. So if you've had a play around with machine learning already, you'll be familiar with some of those terms. And again, this is just the start of it, of quite a long example. So nothing to do with the movies that just came out when I was recording this, Twisters. So this is a data set called Twister. So we pull in the data set, we set some of the terms, Greek letters, we define it, and then we go to a different data set, which in this one is car weights. And first we set the weights, setting the bins for the different car weights. What I like also with these examples is they use comments. And this for Matlab, comments are a percentage. And so it gives you an idea of what it's doing within the text, and then the accompanying text that goes with it has even more details of what you're trying to do. So let me hop back out of here. I was in ANOVA. If I scroll down a little further, we're into regression examples. And I had chosen Bayesian analysis for a logistic regression model. The reason why I chose some and not others is they looked pretty good for demos, so were easy enough to follow along, and they had a specific point. So one of the specific points in this one is that this describes Bayes' theorem. So you can see the math involved with Bayes' theorem, and then it gives you a practical example using it. So the Greek letters are explained in the formula, and then we define the terms here. And then the second one that I was showing you, the car experiment, it explains as it goes, defines the logistic regression model, sets the terms, creates a model, and then shows you the result. And then it gives you an explanation of what the result was. And so in this case, this posterior is elongated along a diagonal line in the parameter space, indicating that after we look at the data, we believe that parameters are correlated. This is interesting since before we collected any data, we assumed they were independent. The correlation comes from combining our prior distribution with the likelihood function. It goes on to go into details on slice sampling, so you can follow along with that one if you choose. So let me hop back over to the presentation. we're going to move on to classification. Again, with your prior knowledge of machine learning, classification is a very significant part of machine learning. An example here shows how to create a classification tree, like so. And then so we're loading ionosphere, which is an indication of how our radar returns. And this is, when you load it, this is what you get. And what we're going to do, view the model, put labels on. And I'm going to hop over back to their site, classification, look at examples. Classification, oh, nope, I chose this one, train a classification ensemble. So usually the second heading in the PowerPoint will be indicate which one I chose. So what this shows is the function that we loaded called fit_c ensemble. Grows shallow trees by default, and you can alter the tree depth by changing around the features. So they've got examples on how to change it around, but this is just a simple example. Okay, I'm going to hop back over to the presentation and move on to a more elaborate, I would say, toolbox. The toolbox has many tools in it, and there are plenty in here, so I'm not going to list all of the ones, but you can look through as curious as you are. So pick dimensionality, reduction of feature extraction. So I'm following along with the workshop, produces results, and then you get the values that are expected to come out of it. I'm not going to go into the details on it, since you can read about those if you are interested, but just to point out again, it's the text that you will cut and paste, the code blocks are pretty good, and then it's got descriptions of what it's doing. Okay, now we're going to move on to probability distributions, so let me take a quick look at that. We were on classifications. We did dimensionality, reduction, and feature extraction. We pick examples out of probability distributions. And we're going to bring up cars small. So again, old data. And in this case, we've decided that there are not that many small cars brands out of Italy. So we're going to exclude Italy. This is what's going on here. So we get a distribution. And let me hop over to here where we compare multiple distribution fits. Explains these steps are needed. So it tells you what we're doing. So we're loading that sample data, car small, and we create an array and define the array. And we're removing Italy from the array. And we're fitting distributions by the grouping. Select our countries, the size of the array. And then we are doing computing the value probability distribution for each distribution. And we're getting a distribution of miles per gallon of cars from the USA. And then you can even go in more detail, miles per gallon by model year. So this one, if you know a little of history from way, way long ago, 1970 was before the oil shock, sometimes called that, when the price of oil shot way, way, way higher. And you can see after that, cars from 1976 started to get more fuel efficient, and even more fuel efficient after in the years following that, because it takes a while to redesign cars. But sometimes the incentives of external factors are what drives efficiency in this case. So here's the examples. First, we created this distribution of cars from the countries, and then we went into more detail, miles per gallon for cars from USA, and we can see the distribution with a histogram and further details. And then when I just showed you the model year, how cars got more efficient over time when you know the history of what happened between 1970 and 76. Okay, hypothesis testing. So we're drawing inferences about a population based on statistical evidence from a sample. We perform t-tests, distribution tests, and non-parametric testing. So in this case, we're looking at gas prices measured across the state of Massachusetts over 2 separate months. Again, I just showed the example of here cutting and pasting from an external source onto Matlab on HPC. So this basic one will load the dataset gas, and we're doing a plot on prices where we compare price 1 to price 2 for the 2 different months. And we're getting means produced from here. So in the on the website, it'll explain what we're doing and what the results mean. It produces p-values. So lots of data, and the significance explained in the text. Goes on a little further, and then we create a box plot. I like box plots. I like visually how they appear. You can get the exact same thing in RStudio as an example, but here it shows the interquartile range and the variance over the 2 months of January and February. So you can see the significance of 1 month going up to the next month, and see that the probability ranges are not, there's significant overlap. All right, this one, I'm not going to go into any more detail on it, just to say that there is a set of tools on industrial statistics. And I chose control charts as an example, and within control charts, you can get a lot of different kinds of data to different charts that can be produced. So I just picked one of those here, an X-bar control chart, using a data set called parts. We define our terms, and then we produce the chart. There are some more. Let me hop back over. So I feel at this point I've shown you how to get around the toolbox, how to use the toolbox on HPC, and how you can go into further detail if you want on Matlab's site. We didn't get into analysis of big data with tall arrays or code generation, but they do have a pretty neat code generation tool, which we could probably save for another presentation. All right, thank you for your time and interest in learning a little more about HPC and using MATLAB for statistics.